Hello and welcome to my channel. In this physics video tutorial, we want to discuss specific latent heat. We want to solve this simple problem we have here, but it is very expedient for you to understand some basic concepts about latent heat of fusion, or say change of state. Or you need to understand that when a given material changes from one form to another, there exists different behavior at the point of transition. The behavior of substance as they transit from one form to another is what we call change of state. So that's exactly what change of state is all about. But there are some concepts under this change of state we need to understand. The first is the latent heat. Don't worry, we also talk about latent heat, specific latent heat, but let's talk about this latent heat. To understand latent heat, when heat is applied to a substance, let's consider the substance to be maybe a solid ice. All right. So what happened to this? Its temperature rises when heat is applied to it steadily until a particular temperature is attained. This particular solid begins to melt. During the course of melting, the temperature of this substance, which is this ice, remains steady throughout the period heat is applied to it. So this heat is not actually visible even as the temperature rise on this body. Uh, we call this process latent heat of fusion. So to define this latent heat of fusion, we will just simply say that the symbol is L subscript F, that the latent heat of fusion of a solid substance is the heat energy required. Let me use some symbol, is the heat energy required to change the substance from the solid form to liquid without any change in temperature. And also to define specific latent heat, the specific latent heat of fusion of a substance is a quantity of heat that is required to change the unit mass of a substance from solid to liquid without the change of temperature. So we have the expression to be Q equal to mass multiplied by latent heat or specific latent heat of fusion. We need to understand the unit for which these things are measured. Mass is in kilogram and latent heat of fusion is in joule per kilogram. So that's the unit. Then ideally, when you have kilogram multiplies by joule per kilogram, of course, you know that this quantity of heat will definitely be measured in joules. That's the unit of the quantity of heat. So if this is well uh, explained, then let's get to work. Let's start solving some problem. We have another concept before we start solving. Rather, we call that you need to be familiar with latent heat of vaporization. And to explain this concept, when water is heated from a known temperature to its boiling point, and you know the boiling point of water is 100 degrees Celsius. When more heat is applied to when more heat is applied at this particular boiling temperature, it continues to boil without change in temperature. This hidden or latent heat is called latent heat of vaporization. You understand? This heat is also used in changing the liquid to vapor. The liquid I'm talking about is water to vapor form. So that's the basics you need to understand about latent heat, specific latent heat, and latent heat of vaporization. So let's solve this problem. An ice block has a mass of, so let's bring out the parameter. The mass is given as 0.05, 15 kilogram. If the specific latent heat of fusion of the ice is 3 points, that specific latent heat of fusion is given as 3 points. 4 times 10 to the fifth power joule per kilogram. What is the heat required to melt the ice block? So that means you're asked to calculate Q, which is the heat required. And the formula to fix this problem is mass multiplied by latent heat of fusion. So Q now, which is the heat required, will be mass is given as 0.15 kilogram, and this would definitely multiply by the latent heat of fusion, which is given as 3.4 times 10 to the fifth power joule per kilogram. All right, of course, you notice at this point kilogram we cancel out with this, leaving us with joules and then this number. So let's use our calculator to check the product of 0.15 times 3.4 times 10 to the fifth power, and the result we have is 51000 joule. You can as well keep this on other larger unit as 51, since it is 30, which is 1000 is kilo, 10 to the power of 3 is same thing as 1000, and that's the same thing as kilo. So you can keep the answer as 51 kilojoules. I hope you found this video helpful. Please make sure to like, subscribe, and hit the notification bell so that by the time I upload new video, you get notified. And make comments. If you can drop a nice comment if you found this video helpful. Thank you for watching. I'll see you in the next video. Bye bye.